The aspect we are going to treat now is what is dipole. Look at the name. We have dipole. Dipole. We know that what the word di simply means what? Two. Pole means what? Charge. So that is what dipole has what? Two charge. And the charge is what? Positive charge and negative what? Of negative charge. That is what? Dipole. So dipole can be defined as what? This is the what? The partial duration of charge in a molecule. Partial creation of what? Of charge in a molecule is called what? Dipole. Dipole simply means what? Charge creation. Two charge creation in a molecule is called dipole. The partial creation of what? Of a molecule in a what? Partial creation of what? Of charge in a what? In a molecule. That's what we call what? Dipole. Take for instance now. Yes, if you have what? H what? HCl. We have H what? HCl. Yes. If the what? Like I said earlier, more negativity, the bond electron will shift towards the chlorine. It will be here. This chlorine now have what? Negative charge. This one will have what? Positive charge. So this is what the two charge we are what? We are talking about. Is the two charge as what we are talking about. But this dipole, it will now lead us to the one we call what? Dipole movement. That what? Dipole movement is known as what? As mu. What? As what? As mu. What is dipole movement? Dipole movement is used to determine dipole movement. This is a quantity. This is the quantity. Quantity dipole movement. This is what? Dipole what? Movement. Movement is used to determine the polarity of what? Of molecule. So dipole moment we use to what? To determine the what? The polarity of a molecule. And it also, stop, it also measure the strength of dipole. The strength of what? Of dipole is measured by what? By dipole moment. And dipole moment can also be used to what? To determine the what? This polarity of a what? Of a molecule. So mathematically, you can also what? Mathematically, you can also define what? Dipole moment moment can be defined as products of charge. This charge, which is what? Q, and distance between the two atoms in the molecule. So, in a what? In a molecule, and dipole, it is a vector quantity. Vector what? Quantity, which is denoted by a straight line with arrow edge and cross tail. So let us look at what the is mathematically dipole movement is the product of what? They said di what? Dipole move what? Movement, which is mu, is equal to the what? Product of what? Of charge, which is q, times what? Distance. So if we look at this thing now, if you have hydrogen chloride Cl, negative charge, positive charge. So the distance between them from here to what? To here is called what? D. So the dipole movement will be what? The charge Q multiplied by what? By distance. That is what? Formula for dipole movement, and is measured in what? Coulomb meter. What? Dipole movement. But I will explain how are we going to what? To use this dipole to what? To determine the polarity. I said here now, this is moved to this side. This is what? Dipole movement with cross tail. I said what? We use what? A straight line with cross tail to represent the what? Dipole. This direction of dipole tells us what? Where the electron what? Shift what? Shift to. So now, we are going to treat what? How are we going to use dipole movement to determine the polarity of the molecule? And there is a particular principle that we used to apply in the vectors in physics under resolution of what? Of forces. So I will try to what? To relate it with what? To the dipole what? Movement, because dipole movement is also a vector what? Quantity. Let us look at it here now. Please recall, in physics, if we have what? If you have a ball like this, and this side I apply a force of what? Of 3 Newton here, and I apply another force of 3 Newton what? Here. Can see that what? The force here is 3 Newton, the force here is 3 Newton. What will be the what? The resultant force or the net force? The net force here will be what? 3 minus 3. Tell us that what? Our net force here is what? Is 0. That is, the ball is going to the what? To none of the two direction. So when you get the net force to be equal to 0, please, the dipole movement also equal to the what? 0. And when the dipole movement is also equal to the 0, therefore, the molecule is what? Is non-polar. Take another one again. I have a ball again in this form, I insert the force of what? Of 7 Newton here, and I insert the what? The force of what? Of 3 Newton here. Please, which direction the ball is going to what? To go. You know that what? The 7 Newton is more than what? Is more than 3. Abi? So, tell that what? The ball will go to the what? 7 Newton direction. Abi now? So, tell you that what? The net force here for this molecule, it will be what? 7 minus what? 3. Abi? If you subtract it now, that is what? The net force is not equal to the what? 0. Whenever the net force is not equal to the 0, the dipole movement is not equal to the what? 0. Therefore, the molecule is what? Is polar. Hope you are getting it now. Okay, in the case of, we have another ball that is moving like this. We have another ball here again, and I insert what? Force here, 3 Newton. I insert another force here, which is 3 Newton. I insert another force here, which is what? 3 what? 3 Newton. Which direction the ball is going to go? Note that what? 3 Newton. Abi? The force are what? Are the same. For this kind of molecule here, the net force is what? The net force is equal to the what? 0. Because the 3 values are what? Are equal, and the ball is going what? Nowhere. It's still remain at what? At rest. So when the net force is equal to 0, the what? The dipole movement is also equal to the what? 0. When dipole movement is equal to the 0, the molecule is what? Is non-polar. But in case of this kind of molecule again, we have ball. I insert what? 3 Newton here. I insert another what? 3 Newton here. And at this side, I insert what? 20 Newton here. You can see that what? This 20 Newton is more than what? 3. So automatically, the ball will go to the what? To this direction. Abi? So what will be the what? The net force here. The net force for this reaction, it will be what? Is not equal to 0. Because 20 is more than what? This. When the net force is not equal to 0, we now have what? The net what? Dipole movement is also not equal to the 0. When the net dipole movement is not equal to 0, the molecule is what? Is polar. The next one, if you have a ball in this form, and here we have what? 3 Newton, we also insert a force of what? 3 Newton here, another force of what? 3 Newton here, another force of what? 3 Newton here. You are now asked to find the what? The net force. Since the force are equal, the net force is equal to the 0, then the net what? Dipole movement is also equal to the 0, then the what? Molecule is what? Is non-polar. See, I just deviate little bit from the vector analysis in physics. So whenever the what? The force here are equal, subtract it to give you 0. Where the have net force is 0, dipole is 0. When any molecule that have 0 dipole, therefore that molecule is non-polar. Likewise here we have 7 Newton, we have 3 Newton. So if you subtract 3 from Newton, 7 is more than what? 3. The ball will move to this side. So because the ball moves to this side, this is what? It tells you that what? The net force is what? Is 4. Abi? So the net force is not equal to 0. The dipole moment is not equal to 0. Then this what? Is polar. Any molecule that have 0 dipole is what? Is not polar. Any molecule without a 0 dipole is what? Is a polar. Let us check it now. Yeah, for example, yeah. mm, for example, yeah. For example, to determine the what polarity of the what, and yes, determine the polarity of the following molecules. What are they? Number one, let us look at what H, no, Cl and Cl. Look at this Cl and Cl now. Assume we insert force of 3 Newton here, the force of what? 3 Newton, 3 Newton. Two of them have what? Of the same force. Whenever we have what? Of the same force, Abi, they will cancel what? Each other. So the net what? The net force here is equal to what? 0. Therefore, net dipole movement is also equal to 0. Therefore, molecule is what? Non-polar. Take another one. If you have what? Oxygen with what? Oxygen. Insert 3 what? 3 Newton here. Insert 3 what? 3 Newton here. They are the same. Oxygen, oxygen. Abi? They will cancel what? Each other. What will be the what? The net force here. The net force is equal to the 0. Then net what? Dipole is also equal to the what? 0. Therefore, molecule is what? Non-polar. Let's check another one. If we have what? Let me use the hydrogen bond with another hydrogen. So the force you put here is 3 Newton. You also have 3 what? 3 Newton. They will cancel each other. The net force, let me call it F, you call it the what? 0. The net dipole movement is also equal to the 0. The molecule is what? Non-polar. Abi? So you can see that what? If you like, check for the what? Nitrogen too. Nitrogen, this have the same 3 Newton. Here we also have what? 3 Newton. They will cancel each other. So the net force will be equal to the what? 0. Net dipole will equal to the what? 0. The molecule is what? Is non what? Polar. Abi? Okay, let us check for what? This molecule, hydrogen chloride. So you know that what? They are of different what? They are of different negativity. Let me say what? Here is 5 Newton. This place is what? 3 what? The, oh God. Yeah. Let's check for hydrogen what? Chloride. Chloride. Abi? So the first here is what? 3 Newton. The first here is what? 5 Newton. So you can see that what? This 5 is greater than what? This. Because this one is what? Is chlorine. Abi? You are don't have to assume the value. So at the end of the day, the bond will shift to this side, abi? So you now put your what? Your dipole symbol like this. This is the dipole symbol. That is what it should shift like this. Therefore, the net force here, net force here is not equal to 0. Then net dipole movement is not equal to what? 0. When the dipole movement is not equal to 0, what will happen now? The molecule is what? Is polar. The molecule is what? Is polar. Let's check another molecule again. If we have a molecule like one like this, we have water, H, like this. We have oxygen, lone pair here, we have lone pair here. This lone pair will draw like this. This one will also was draw like this now. Yes, good. And the electron here, don't let me use that place. That place is small. It's small for this. Before water, sorry, let me look at what that of what BF3. The BF3, we have B a what? BF3. BF3 is this F, F, and what? And F. Look at this now. The 3. Call this place what? Give him what? 3 what? Newton. This is also what? 3 Newton. And this side is also what? 3 what? Newton. Abi? So 3 Newtons are what? Are equal here. Therefore, the net what? Net force is not equal to the what? Is equal to 0. Sorry. Because FF round. So the net dipole here is also equal to 0. Therefore, BF3 is what? Is molecule is non-polar. And look at another one again. If we have what? For CH4, methane. Look at methane. We have it in this form. Methane. They are equal. Abi? That is, we insert what? 3 Newton here. This also what? 3 Newton. This also what? 3 what? Newton. This also what? 3 what? Newton. They are equal. They will cancel what? Each other. The net force here is equal to 0. Net dipole will also equal to 0. Therefore, molecule is what? Is non-polar. Abi? But in the case of we have CH3 Cl. Look at CH3 Cl. CH3 Cl is look like this. Monochloro what? Methane. So if you put what? 3 Newton here, 3 Newton here, 3 Newton here, Abi? And look at what this man alone, it will not take what? Put force of 20 what? Newton on him. You will observe that what? The direction of dipole will face this side, and this place will become positive charge. Here we have negative what? Negative charge. So for this kind of what? Of this, the chlorine is more negative than what? Than this one. We now call it what? Net dipole. Net force is not equal to 0. Net dipole is not equal to 0. Therefore, this molecule is a what? Is a polar. Mole what? molecule. And let us look at what in case of what Na3, which is ammonia. Ammonia has what NH, H, H, double bond there. This lone pair of electron here, pull. So this thing will go like this, to go like this. Everything will go like this. So the dipole direction will be this. The ammonia is also what? The net force here is not equal to 0. Net dipole equal to what? Not equal to 0. And the molecule is a what? Is a polar. So let us look at another one for CO2. So CO2 we have in linear shape like this. So we can see that what? This is what? Going like this, and this also going like this. If they have the same knitting, so there's no what? Therefore, the net force here, the net force is equal to 0. The net dipole movement is also equal to 0. Therefore, is not what? The molecule is polar. Let us look at what? Yes, the molecule is not what? Is not what? Is not polar. In case of what? Of SO2, the SO2 is double bond here. It has what? This bond with what? Lone pair of what? Electron here. So can say that what? This here and this here. So the SO2 net dipole molecule is not equal to 0. Therefore, is a polar what? Is a polar molecule. In case of what? Ethanol, which is what? We have CH3O what? OH, which is what? Now, COOHHH. Yes. So like this one now, the force pressure up on oxygen. Assume it will be what? Is more electronegativity. You can put 20 here. You put 3 here. So this one net what? Force will be not equal to what? 0. Net dipole molecule is not equal to what? 0. Therefore, the molecule is a polar molecule, or is dipole molecule. The what? Molecule is a polar. So this is how can use what? The dipole movement to determine the polarity of a what? Of a molecule. So if you could still remember, said we can use two quantity to determine the polarity of a molecule. I said the first one is what? By using what? Dipole what? Dipole movement. Are we? And the second one I said by using what? Electronegativity. So that's where we are going to stop for today. So in my next class, I will continue from the what? From the theory of covalent what? Theory of covalent what? Of covalent bonds. So and the theory of covalent bond is comprised of what we call what? We have VESPA, electron, valency, charge, repulsion theory. electron valency electron valency shell, repulsion, repulsion. Is that we used to call it what? Fair what? First, Vesper and valency orbital theory and molecular orbital theory. So in the next class, we are going to what to explain theory of what of covalent bond. So after that, we move to the what dative bond, dative bond, metallic bond, and we are now done with what intramolecular bond.